Okay, here we are, and we are into version 4 of this Noughts and Crosses programming project. Thank you for joining me here and continuing to dedicate a little bit of your life to making this Noughts and Crosses game with me. Now, we are going to be getting in some of the victory conditions at the moment because last version we made this lovely looking. Ignore the fact that it's all like off kilter. Don't worry about that. That's fine. But we're gonna fix that. That's a little thing. The functional side of my brain just wants to get the game working. So we've got this state here where we can actually. Oh no! Why isn't it working? It's all gone wrong. This was working when we left it yesterday. What happened? Okay, we'll fix that. But we got this so that it was swapping the turns between Alice and Bob, and it was doing this. I must have done something silly, for sure. Self.start, and then up here. Oh right, we never set the game to true. If game is false, but we're returning true here. Okay, yeah. So this is what we're going to do today. So if we have a look at the to-do list, we have created the game board, we've added the player information at the top, we've added player turns, and we skipped this one, add victory condition logic. So that's what we're going to do today. So here, where I've got 3 noughts, obviously there'd be crosses in the game as well, but where we've got 3 noughts, technically someone has won now, and so we need to make the game identify that someone has won. Now, the first thing that we need to do is go to the game board and address a bit of an issue. Actually, let me just open up these in tabs so I don't have to keep opening this over and over again. Okay, lovely. Let's close that down. Okay, so in the game boards here, let me hide that as well. That's better. Let's bring this up. Okay. These buttons, I'm just finding them obnoxiously big, but we'll have to persevere. Okay. So in our game board, we are storing all of our spaces in this array. So we've made this class game board in gameboard.py, and when we create a space down here in our create board method, we are creating all of our different spaces, right? And we're just throwing them into an array. And what would be helpful is if we were more thoughtful about how we're storing them in the array. So rather than just having a big list of spaces, it would be quite nice if you can see here we're doing X and Y coordinates, right? So it would be really nice if all of the spaces in the same row, so this space here, and this space here, if they were all in their own separate array, if they're in their own row, so that I can identify those that are in a row, and then we can do the same with the other rows. So what we're going to do is every time that we say for Y in range, so for each row as we go down, yeah, we're going to put all of the columns for that row inside an array. So we're going to say row equals an empty array. And then instead of saying self.spaces.append, we're going to say row.append. Okay? So we're going to add that space to our row. So we're going to go for X in range, board size. So we're going to 3 times. We're going to add a space and then a next X. So it'll be 1 over, add a space, 1 over, add a space. And then those 3 spaces will be in an array. Okay, then what we're going to do is we're going to rename this here, this property self.spaces. We're going to rename this to grid. Okay, and I don't think at this point in the program that this is going to disrupt anything. I don't think we've actually referenced this at all, really, the grid yet. So that's fine. We can just change that, and that's kind of it's not gonna blow anything up. And we're going to say after we've looped through, so down here, once we've done this 3 times, we're then going to add that row to our grid. So we're going to say self.grid.append row. And then what's going to happen is we're going to come back to the top of this loop. We're going to increase Y by 1. So we're going to drop down the grid by 1. And then we're going to put in the middle 3 columns. Yeah? We're going to add them all to a row. And then we're going to put that row in our grid. And so our self.grid is going to look like this. Where we have... oh dear. Oh no. Help. Where we have 3 arrays, each with something in them. So I'm just going to put an X in them just to show that there is something in them. Okay, and each one of these will be a space. And so if I wanted to look at, let's say, the middle one here, I could say, well, it's in row 1. Okay, so we've got row 0, row 1, row 2. I could say it's in row 1 and it's in column. Let's have a look. Oh, come back. It's in column 0, 1, 2, like that. Okay, so I could say self.grid 1, 1, and that would get me this space here. Okay, and this is going to be really crucial for me being able to check the victory condition and whether someone's won by a diagonal or an across or a down. So we're going to have a little look at how we can implement that, but we need to have this grid in place in order to do this, and that's how we've just kind of made a little amendment to this code. We're adding our spaces to a row, and then we're adding each row, each array to our grid. And so this array here will be an array of arrays. Okay, fantastic. So this is all good now. So we're going to go over to our main function. I'm going to come down, and where we've got this check victory condition, this is where we're going to do all of the checking. Okay, so what we need to do first is we're going to check the rows. Okay, we're going to start off nice and easily. So we're going to check each row to see if that row has all of the same symbol in it. And if it doesn't have all of the same symbol, if it has a hyphen in it, we know there cannot be a winning condition in that row. Because if it has a hyphen, that means it's not full. And so, like, if I was to click here and here, if this row has a hyphen, okay, we know that this row can't be a winning row. This row can be because it doesn't have a hyphen in it. So that's one of the key things we will use to decide this. We'll also know it's not a winning row if it has two different symbols, right? It can only have one or the other. We also know that only the current turn, whoever's current turn it is, can actually be winning, right? We're only checking for the person that most recently played, because you can't play your go and then the other player wins. If you play your go, you're either going to win or you're going to draw. Okay, it's only when the other player plays that they have a chance of winning. It's not like, I don't know, football where you could accidentally kick the ball and it bounce off one end of the field and go up the other and score into your own goal. You can't score an own goal like that in noughts and crosses. And so what we're going to do is we're going to write some functions on the game board. Okay. So we're going to tell the game board, self.gameboard, we're going to tell it to check rows. Okay, and we are going to say victory. Yeah, let's just store this in a variable called victory at the moment. So check rows doesn't exist, and also I guess I should stick to my naming convention and have a capital R there. So we're going to go and write that now. Now, one thing we are going to be passing in is whoever's current turn it is. So we're going to say self.currentTurn. So that when we are checking the rows, we know we can just check for that symbol. And if there's 3 of that symbol, then great, we win. Okay, so let's go to our game board then. And let's implement this function, check rows. Now, I'm doing it in the game board because the game board is where we have the grid stored, right? We have the grids with all of our rows in it, so it'll be nice and easy to put it in here. So let's jump down here, and we're going to say def check rows. We are going to expect the player symbol. Okay, whoever's go it is, we're going to expect their symbol, and I've just literally programmed that in, right? So here I said check rows, and I'm passing in self.currentTurn. That's our player's symbol. And so when we go to the game board, when we're actually implementing check rows, we're expecting that player symbol. Also, what I need to do is I need to obviously give the self. We must never forget the self. Always remember the self. Okay. Now, in order to check rows, we could do this. We could do this using a loop, or well, we will do this using a loop. So we're going to go for row in self.grid. Okay, because our grid has just 3 arrays in it, right, that are storing our different rows. So we're going to have a look at each of those rows, and what we're going to do is we're going to make a test row. This is a little bit silly, right? But it will work. We're going to fill it with player symbol. Okay, so this is our test row, and it's got 3 lots of the player symbol in it in the array. Okay, so our test row has maybe 3 noughts in it or 3 crosses in it, and we're just going to check to see whether there is a row in our grid that is the same. That doesn't work though, does it? Because our grid isn't full of just zeros, it's actually full of spaces which have content. So what we're going to have to do is we're going to have to say for space in row. So we're going to have to get each space, and we're going to have to get the symbol. Did we say get anything in here? No. So we're going to make a quick method in our space class, and we're going to say def get contents. We need the self, and we're attaching this to the space class. Let me just hide these. Okay, and we are going to say self dot, I'm hiding this, but of course I need to see what I'm referring to. Self dot contents, and I want to dot get it. So I'm going to say self dot contents dot get, and we are going to return that value. So whatever self dot contents dot gets whatever it returns, we are going to be using that value, and so we're going to return that. And so here we can say for space in row, and let's say test row, let's have grid row equals an empty array. We can say for space in row, grid row dot append, and we're going to add in our space dot get contents. Okay, and that's going to get the contents of our space, whether it's an X or a 0 or a hyphen, and it's going to put that in our grid row. Yeah, and then once we've built our grid row, it's going to have 3 values in here. It might be, you know, a hyphen, an X, and an X. Okay, and once it's built that, obviously we're not going to leave it like this, I'm going to delete these, but once it's built that, we're then going to compare it to our test row, and if it's the same as our test row, if it's equal to, then we're going to return true because someone has 1. Okay, because our test row is just full of the player symbol. Make sense? If it's not, then we're going to test the other rows, and if we test all the rows and none of them return true, then we'll just return false at the end. So grid row dot append. And so we go through each space, we add to the grid row those different contents, and then we're going to say, what are we going to say? We're going to say if grid row is equal to test row, and we can compare arrays just like we can strings or numbers, okay, so which is quite handy. And I'm going to say return true. So if they are equal, return true. If we get through all of this, right at the bottom here, if we get through all of this and the for loop ends and we didn't return true, so the function just kept on going, as soon as we get to return, the function stops. It's like, boom, done, I'm finished. Even if we only did 1 row and 1 space, well, this isn't in that, but even if we did 1 row and it got to here, it would just return true and this would stop running. That's the beauty of the return keyword. So right at the end here, we're going to say return false. So if we checked all the rows and none of them matched our test row, then we're going to return false. Now this, we'll check to see whether we've got a win in here, okay? Now, we then need to update the winning player. So in our player, do we have a set status? Yeah, we do. Okay, so we can set that player's status. Do we have a change status, get status, set status, reset stats? Okay, so we're gonna set their status just to check this is working, right? So we're gonna say if victory, if victory is true, then we are going to what we're going to do. We are going to set our player's status. So we're going to say, I guess we need a way of like getting the current player whose turn it is. That would be a handy, yeah, that would be a handy method to write here actually. Wow, we've got a lot of code here. Okay, so let's just come down here. Where have we got some players? Create players. So I'm just going to pop it in here. I'm going to say def get current player. This may be a little bit overboard, but I quite like to encapsulate things inside methods and functions. So we're going to get the current player, and what we're going to do is we are going to go through our different players. So we're going to say for player in self.players, and we are going to say if player.get I want their symbol. We can't say get symbol. That's annoying. Let's add that. So let's go. Let's always jumping around so much. I really apologize. Let's go into our player and let's write a method for getting symbol. So just here under get status, I'm going to write def get symbol, and we're going to say self, and we are going to return self.stats symbol.get. In fact, what I'm going to do is I'm just going to copy this from get status and change the word status, because don't work smarter, work harder. So let's change this to symbol. Okay, so here we've got def get symbol, and then we are returning, we're getting that symbol. Okay, this just makes it a bit cleaner by having it. I know we could just like say player.stats symbol.get in the main code, but just makes it a bit cleaner in terms of implementation. So if we go back to our main function, so now we can say if player.getSymbol is equal to self.playerTurn. Is it playerTurn? What is it? Self.currentTurn, not playerTurn. Self.currentTurn. Then we are going to return that player. Okay. Now we should always return one of the players. Okay. If we don't return a player, something's gone horribly wrong. So we're going to return, I don't know, false. Okay, or because it's not worked. But this should just get our current player. So this will actually return us that player class that's storing their name and their how many wins they've got and all of this stuff, and has all these methods attached. So then we can use that in the rest of our code. So if we come up to our get victory condition, we can say player equals self.get current player, and then we're going to say player dot, what we're going to say, player dot change status, and we are going to give it the status of winner. I said it, didn't I? Bad. Player dot change status winner. Yeah, I don't like that. I don't like that at all, actually, thinking about it. It makes more sense. I'm going to leave... I'm going to leave that in here, but I'm going to take this code, actually. And so I'm going to take this code from get current player. I'm going to copy it, because I think, actually, it makes more sense to use it up here, right? Because actually, when we check the victory condition, we don't just want to do something to the player that won, we also want to be able to change the status of the player that lost as well. We don't want them to just say, you know, like waiting. So what we're going to do is we're going to say victory, if victory is true, we're going to go through our players. So for player in self.players, we're going to say if player.getSymbol equals self.currentTurn, then we're going to say player.changeStatus. I'm sorry, I've flipped around here. That's development for you. I never said we'd be perfect the first time, that's for sure. So if our victory is true, we then go through each player. If the player is the current turn, then we're going to change their status to winner. Else, we're going to change their status to loser. Seems overly harsh, but let's change their status to loser. Okay, and we are going to, right at the end of our function, we're going to return our victory. So whatever our victory is, whether it's true or whether it's false, we're going to return that. Okay. So now we can run this, and the game should work. We should have different turns. We won't be able to win by getting a diagonal or a column, but we should be able to test this as a proof of concept and see whether, when we put 3 of the same character in a row, whether the game detects that and tells the correct player they've won. So let's do a couple of tests on this and see. So let's run this. Okay, so I'm starting as Alice, so I'm gonna go for an X win. Okay, I'm gonna try and make Alice win. So X, and now it's Bob's turn. Good, this is working again. So I'm gonna go say 0, X, 0, X, and and a big error there. I already know what I've done. The error is hidden behind me here, so you might not be able to see it. It might have happened on your computer as well. Who knows? Or you might have been cleverer than me, and you've made a mistake there, and you're about to find out. But you were like, "I'll correct that now, and I'll just wait for him to find out." That's fine. So in my player, in my Oh no. Okay, I used change status, but I should have used set status. I've not named these very well, have I? This should have been flip status. I said yesterday in the last version, this should have said flip status. That makes so much more sense. Okay, let's go back to main. Instead of saying change, we're going to say set. So here, we're going to say set status. Set status. Okay, because we're setting it. Flip would have made so much more sense. Anyway, I'm over it. So let's run this again. This is why we test. So it's Bob's turn this time. Okay. Did we put that random thing in last version? I can't even remember. Okay, great. So Bob's. I'm still going to go for an X win though. So I'm going to put Bob there. I'm going to put Alice there. Bob there. Alice there. Bob there. Alice there. Look at that. We've got 3 X's in a row here, and Alice's symbol with the X is her status is the winner, and Bob's symbol with the O is status is the loser. Now, what would be really nice at this point is if Alice's wins went up by 1, and Bob's losses went up by 1 as well. Yeah? So what we're going to do is we are going to add another method to the player, and this is going to essentially add a win, a draw, or a loss to the player's stats, right? So inside here, we're going to say def add result. Okay. Ooh. Add result. And the result that we're going to add, well, we need to put the self in first. The result we're going to add is just going to be a string, either wins, draws, losses. Okay. And then we'll use that to target which stat we need to increase by 1. No matter if they win, lose, or draw, we're going to add 1 to some number. Okay. So we're not going to, if they lose, we're not going to take 1 away from their wins or do anything weird like that. We're just going to add 1 to whatever it is. So we're going to say, what are we going to call this? Oh, it's the little names that always throw me. So we're going to add result. I guess we could just call this result, right? And we're going to say self.stats at position result. Okay, so we're going to pass into this method either wins, draws, or losses. We're going to say dot set, and we are going to, I guess we need to get it first, don't we? Yeah, we need to get it. So we're going to say current total equals, and we're going to do self.stats result.get. So we're going to get that number. And then down here, we're going to say set to current total plus 1. And now, if we were to put in result to this method here, okay, and the result was the string wins, then it would look up, to find the current total, it would look up self.stats wins and say .get. So it would get whatever value was stored in wins. And then it would come down to the next line, and it would say self.stats result, so wins again, and it would set that to whatever our current total was that we got, add 1. Now, we're resetting these to 0. Okay, fantastic, good. Good, good, good. Yeah, because they're all 0 there. So now what we can do is we can come up to back to our main function, and when we're saying player.setStatus, we can also say player.addResult, and we're going to add wins for this player, and I think I called it losses, so we'll say player on this line here, player.addResult, and we're going to say losses. Let me just double check that I called it losses. Yeah, I did. Okay, fantastic. And so what this will do is, regardless of what player won or what which one lost, we will add 1 to the correct player. Okay, because we know we get in the program to work out who's won, right? Because whoever's current turn it is the winner. Because we haven't changed the turn, we check the victory condition before we change the turn. So this is good. This is good. This is good. Now, if there's a draw, then we need to we need to think about that as well. But we're not quite there yet. We still got some victory conditions to check. So we've checked all the rows, right? Now, what I haven't tested is whether Noughts it will detect Noughts. So let's make Noughts win, and also we're going to test the wins and losses and see if that happens at the same time. So here we go. It is Noughts go first. That's good. Nought cross, Nought. Hooray! Bob won, and look at this. Bob's got 1 win. And Alice has 1 loss, which is fantastic. So we've incremented those, and if we had a way to reset the game, we would then be able to play again and see those numbers get larger and larger as we play more and more games within this session. This is great. So now what we need to do is we need to add the other victory conditions, because at the moment, when I play this, I could do this and go down like this, and I should have won now. Okay, Bob should have won because he's got 3 in a row. So we need to check the columns. So let's jump over to our game board and let's write a method that will check the columns. So we're going to say def. It's going to be very similar to check rows, okay? We're going to say def check columns. And I'm half tempted just to copy the check rows and then just all the code inside there and then just butcher it. But I don't think as a viewer that would that would be very nice to follow. So maybe we won't. So we're going to give it the player symbol once again. Okay, and we are going to have our test row absolutely the same. Okay, our test row is just going to be 3 lots of the player symbol in this array. Okay, now what we're going to do is we're going to go through each row in the grid, but we only want the first, the very first space. Yeah, so we're going to say for row in self.grid. We want to take that very first space, okay? To build our column. So we're going to say, what are we going to say? We're going to say, what did we say up here? For space in row. Yeah, so I guess what we really want to do is we want maybe a count controlled loop here. Yeah, so let's, above that, let's say for x in, for x in range. Sorry, I had a moment there. And do we have self.board size here? Yeah, we do. So for x in range, self.board size. Okay, so the board size is 3, the length of a row. So our x is going to be going along, and each row is going to be going down. Okay. Now, we want to take our very first thing in that row. So we want row at position I. Yeah. So when x is 0, we want row at position I. So this row here, at position I, which will be 0 here, and then we're going to go down the next row. And so row at position 0 will be this one. And then we're going to go down the next row, and row at position 0 will be this one. Okay? Then this loop will have finished. Okay? Because we'll run out of rows. And so we'll come back to the top, and x will get bigger by 1. So we'll move over when we come down here to do this again for row in self.grid. We will be talking about this row again, but this column now instead. Okay? And then row will go down, and it will be this column. This row, and that will be those 3 in that column. And so this is our algorithm for going through column by column. Okay, So row I will be a space, and we want to say space.get contents. So we're going to get the contents from whatever space is in that row at that position. And we need to add that to our grid column. So here we're going to say grid. You might notice a very, very similar resemblance to the method above right now. So grid column is equal to an empty array. And then down here, we're going to say, we could call it something like space equals row.get contents. And then we're going to say grid column. You could just do this in one line. I like to, I don't know. Sometimes it's nice just to have a bit of breathing room. And we're going to say grid column.append space. And so we're going to add that space to our grid column, right? And so this is going to take, so for instance, this board here, it would fill it with an X, a 0, and an X before this loop finished for the first time. And then down here, once we've got that grid column with its 3 values in, we're then going to compare it to our test row. Our test row is full of the winning player's symbol. And if it matches that array of the winning player symbol, then we know they've won by a column. If it doesn't match that, then we know that this particular column doesn't have the victory condition in it. So we're going to say if our test row is equal to our grid column. Oh, I called this test row. Let's call this test column. Otherwise, it's just not going to be any fun, is it? It's fun. It's not going to make any sense. Grid column. Okay, so our test column, if it's equal to our grid column, then we're going to return true, just like we did in the previous one. Okay. However, if it doesn't return true, then we are going to, what are we going to do? Why is this having a problem? Space.get contents, undefined name I. Oh, I called it, okay. I said row I, I'm just so used to having I in a for loop. I called this X because it's like our X coordinate moving along. So it should be row X, not row I. My bad. So this is good. So then if we get through all of that and we don't manage to return true at any point, then we know that there's no victory condition. We can continue playing the game, so we're going to return false. Fantastic. So now what we're going to do is we're going to jump into main. Okay, and we're checking the victory here. And then we are doing an if statement. Now, really, I guess we could do some like Boolean logic here. Let's do some Boolean logic. I think this will be quite nice. So we're going to say row victory equals this, okay? And then we're going to say column victory. So I'm back in the main function now. In our check victory condition method in the noughts and crosses class, we're going to say column victory is equal to self.gameboard dot check rows, and we're going to give it our self.current turn. And now what we're going to do is we're going to say victory is equal to row victory or column victory. Okay, so if at least one of these is true, and only one can really be true, I'm pretty sure. Yeah, I don't think you can win. Maybe you could win by like a row and a column victory in like a really insane game. Yeah, you could. You could technically win by both. But as long as one of these are true, then victory will be true, right? Because this condition here is going to boil down to true or false. Okay, because row victory is going to be either true or false, and column victory is going to be either true or false. And if this is false and this is false, then victory is going to be false. If one of these is true, or both are true, then victory is going to be true. Okay, lovely. And if it is true, then we do all of this. So now we've just implemented our way to check whether someone's won by a column. So let's just test this now. It didn't work last time, but let's try it now. So I'm going to click in here. I'll get a 0. Okay. And okay, that didn't work. Why didn't it? Because I said check rows. Oh dear. Okay. Obviously, if we check in the rows twice, then we're not gonna get any idea of what's going on in the columns because we're too busy checking the rows over and over again. Let's check the columns, okay? That's, again, my bad. So we got row victory is self.gameboard.check rows, and then column victory is self.gameboard.check columns. We're passing in the current turn. Let's have a look and gaze in awe as this works. Fantastic. And we can see here Alice, who is crosses, is the winner. Her wins have gone up, Bob's losses have gone up, and we can see that she has won with a column victory. Okay, and let's just check that we can still work, that it still works by winning with a row victory. So if I go X, oh no, hang on, I forgot how to play noughts and crosses for a second there. If we go X, naught, X, naught, X, great. Alice wins with the X going across. Okay, so we can see here that we are able to get a row victory and a column victory. So now it is the little bit more difficult part where we've got to check a diagonal victory. Okay, so this is going to be, you're going to have to bear with me here. Okay, this is going to be just a little bit more intense than the other ones, probably. Maybe not. Diagonal victory is equal to self.game gameboard dot, oh no, choose my changes, they're much better. Self.gameboard.check diagonals, and we are going to pass in self.current turn. Now it's going to complain at me because check diagonals doesn't exist, and also diagonal victory is assigned but never used. Okay, so self.gameboard.check diagonal. So it's going to work in just the same way as the others. So we'll go over to the game boards where we've got our lots of different methods here. Let's close some of these up. Check rows, check columns. Okay, so now we're going to add check diagonals. So def check diagonals. I really can't spell that today. We're going to add in the self and we're going to add in the player symbol. Okay, I'm going to need visuals for this, so let's just run the game. It doesn't like this because I've just left this empty, so I'm just going to put return true as a placeholder. And if I run this just to get the board up. Hello, repl.it. Any danger of running my code, if you wouldn't mind? Oh, I've lost all my tabs. Okay, that's okay. We will persevere. Right, let me just reopen these. That's one downside to working in the cloud. Okay. Here we go. So, we've got our game board, create game board, check rows, check columns, check diagonals. Okay, so what we need to do is we need to go, at the same time, we need to increase our X coordinate and our Y coordinate, so they're both the same value essentially, right? Because if we were to think of this as a grid here, we've got this square here as being at coordinate 0, 0, this coordinate at 1, 1, and this coordinate at 2, 2, right? So we've got one coordinate just twice to check each diagonal here, and then we'll worry about this this backwards one in a little bit. So the first diagonal, so we want we're going to do this in two stages. We're going to check left, top left to bottom right. Okay, we're going to check that one first. So we're going to do exactly the same as we did in the last two. We're going to have our test diagonal. So I'm just going to copy that array from check columns, and we're going to build that with our player symbol. And instead of test column, I'm going to call this test diagonal. Okay, lovely. I feel like I've got less screen space than I did have. Okay. So that's great. So now what we need to do is we need to gather all of the values of these three squares, these three spaces, and see whether they are equal to our test diagonal, right? So we're just going to add them to an array like usual. So we're going to say for, let's say, what should we do? Let's say for row in self.grid. So we'll go through each row, and we're going to want to get row at position X, and we can just have X get one bigger each time, right? Yeah, that's fine. So we'll say row X, and we'll do the same here. So we'll say for I in range, what is it? Self.board size. Board size, lovely. So for I in range, not I, X, for X in range, self.board size, for row in self.grid, no, we don't need this, no, sorry. My brain thought of something clever to begin with, and then it talked itself out of it, and now I've realised it was clever in the first place. So we're going to make a variable called X above this loop. I'm sorry, I've added a loop, I've got rid of a loop. Okay, we're back to like 2 minutes ago. So we're going to say X is equal to 0, right? And then we're going to say for row in self.grid, we want to take that row X and we want to get the content. So we're going to say row X dot get contents. And we're going to get the contents of that, and we're going to add it to our grid. So we're going to say grid diagonal. Is that the naming convention we've been using in the other ones? This feels like it. Grid diagonal equals an empty array. And then we're going to say space equals, space is a bad word, but hey ho. And then we're going to say grid diagonal dot append that space. I guess we could call it symbol. Let's call it symbol. That's much better. Makes more sense. Let's call this symbol. Okay, fantastic stuff. So we've got our test diagonal array with the player information that we want. We've created this variable called X, and we've created this array called grid diagonal. So we're going to go through each row in our grid, and we're going to take from whatever X is. Okay, so X starts at 0, so we're going to take from the very first, in the first row, we're going to take the very first thing in that array. And we're going to get the contents, and we're going to add that symbol to grid diagonal. Lastly, we're going to say X is plus equals 1. So we're going to add 1 to X. So X then, as we come back up to the top of the loop, X becomes 1. So for the next row, instead of looking at the first thing, so now we're on this row, instead of looking at the first thing, we're going to look at the thing at position 1. This is at position 0. So we're going to have a look at this thing, position 1 here. So we'll be looking at this. And then we're going to add that symbol to the array. And then we're going to add 1 to X, and X is going to become 2. And so when we look at the next row, this third row, any of these three here, we're going to be saying, I want to look at specifically the space at position 2. So X is 2, row at position 2. We're going to look at 0, 1, 2. We'll be looking at this one here. And so we'll have values from these three diagonals being added to our spaces, being added to our grid diagonal. And now what we can do is we can just do a simple test like we did in the other ones. We can say if test diagonal is equal to our grid diagonal, then return true. Now, we don't need to, we only need to do this once, right? We just check in this one diagonal. There's only, whereas there's 3 rows and 3 columns in this game, there's only 2 diagonals. So we've written code to check this one diagonal. Now we're going to write code to check the other diagonal. Now the other diagonal, we're going to start in the, we're going to do exactly the same thing, really. Oh, we are going to do the same thing. I have a plan. This could be good because we can abstract this, right? We can make this a little bit cleverer. Yeah, because essentially we're going to do exactly the same thing, but X is going to start at 2. So it's going to start over here on this right-hand side on the first row. And then instead of going up and adding 1 to it each time, we're just going to subtract 1 from it each time. So let's make a, this is going to be really annoying, but we're going to make a singular name here. So we're going to say def check diagonal. Okay, and we're going to check 1 diagonal in this function. And there's going to be a bit of a copy and paste job here, but well, a cut and paste, right? Not copy, cut. So we're going to move all of this code here, all of this. So everything but test diagonal, we're going to cut that and we're going to pop it into check diagonal. And now we're just going to abstract this a little bit. So we're going to pass in to check diagonal, we're going to pass in our start value for x. So start x, okay? And so instead of saying x equals 0, we're just going to say x equals start x. I guess technically we don't need that. Let's just leave it in. Let's not overcomplicate it. Or would they undercomplicate it? I don't know. So this now, x will be whatever we pass in. So when we check our first diagonal, we're going to start x at 0. When we check our second one, we're going to start it at 2. Now we also need to add in the increment. So how much is x getting bigger by? Well, when we first do this one, x is getting bigger by 1 because it starts at 0, then we want it to be 1, and then we want it to be 2. But here, when it starts at 2, we actually want it to increment by -1 because we want it to now go backwards by 1 and then backwards by 1 again. So what we're going to do is we're going to say x plus equals increment, and that is going to either be positive or -1. Okay. Last, I guess in somewhere in here we need the test diagonal, right? So I'm just going to take this variable name and I'm going to paste it here. So we're going to pass in 3 things to this method when we call it. Self is invisible, we can ignore that. But we're going to pass in the test diagonal array, we're going to pass in the starting position for x, and we're going to pass in the increment for x. So now what I can do, we've done something very clever here. Very, very clever. We can write a variable, sorry, that sounded like an idiot then. We're going to make a variable called diagonal1, and we're going to set that equal to check diagonal. Okay. And then what we're going to do, then we are going to, what are we going to do? What are we going to do? I've lost the plot. We're going to put in our test diagonal, diagonal. I really hate this word. We're going to put in our test diagonal array. We're going to put in our x value. So when we check our left to right one, we're going to do start at 0 and we're going to add 1 to x. Okay. I'm going to copy this whole thing and I'm going to paste it down here. And my diagonal 2 is going to start at position 2. Yeah. So over here on this corner. So we've got 0, 1, 2. Start over here. And then we're going to go backwards. So we're going to do -1 in here. So we're going to take 1 away and we're going to check that diagonal. Then what we're going to do is we're going to return diagonal 1 or diagonal 2. There's that or thing again, right? So if diagonal 1 is true or diagonal 2 is true, we'll return true. Otherwise, we'll return false. So if none of these work, and also I've put check diagonal, obviously this needs to be self.checkDiagonal. Self.checkDiagonal, and that will work. Okay, so we're passing in this array, this test diagonal. I can't wait to not say the word diagonal, believe me. And we're starting at 0 in the first one and incrementing by 1. And on the next one, we're starting at 2 and we're decrementing. Well, we're incrementing, but by -1. So we're getting smaller. We're going down there. And this has meant that we haven't had to take this whole blob of code and like copy and paste it one under the other. We've actually been a little bit thoughtful about the patterns here and how we can just apply change a couple of variables. Literally, we're just changing 0 and 1, aren't we? And to 2 and -1, and we're getting a completely different diagonal, which is really nice. We're going to return that, and that will give us whether we have a diagonal victory or not. So return diagonal 1 or diagonal 2. So now, for the big reveal, if we go to our main function and come down to check victory condition, we can see here that I already put in diagonal victory equals self.gameboard.checkDiagonals self.current10. So that's all fine. But here, when we say victory, we want to say equals row victory or column victory or diagonal victory. No, I'm trying to not type it. I'm trying to be lazy. It didn't work. Victory equals row victory or column victory or diagonal victory. So as long as one of those are true, we will have a victory. Let's have a look if our diagonals work. Oh, I really hope they do. Do you know what? That actually went a lot smoother than I thought it would. I had visions of having these horrible loops where everything was flying around, but that was actually I don't know how you feel about it, but I felt that went pretty well. So we're going to pop in an X there. Wait, why aren't we swapping? Why? Who's a winner? Wait, what? Oh no. Oh no. You instantly win the game. Oh, okay, right, yeah, I've got to return true. I'm sorry if you've been screening here. Right, so look here. Um, if test diagonal equals grid diagonal, return true. And then right at the end, we just return true as well. Like, oh, even if it's not return true, that's fine. No, so if it doesn't equal, so really I guess we should have an else here, right? So we should say else, return false. Because if it doesn't equal, if our grid diagonal doesn't equal our test diagonal, then no, there's no victory here. Okay, let's run this, and hopefully we can have a longer game than just one turn. So that was just in the game boards class, the method for check diagonal. I just needed this else statement in, else return false. It's just causing all kinds of chaos. So now we can see that it is Alice's turn. She is X's, and I'm going to test this with Bob's Noughts and see if he wins. He does win! Fantastic! So we can see here that we can have a diagonal victory, which is lovely, which is great. So now let's run this again and see if we can have the opposite diagonal victory. So let's see if we can take Alice to victory this time. Bosh, bosh, bosh. And she wins. Fantastic. So we've almost got all of the victory condition logic in, but there is one more way that a game can end, right? We've got rows, we've got columns, we've got diagonals. What's the one way like 90% of all noughts and crosses games end? In a draw. Absolutely. You're 100% right. We need to check whether it's been a draw or not. And how do we know whether it's a draw or not? Do we have to do some like crazy logic and just, well, if there's no row victories and if there's no column victories and if there's no diagonal victories and if, for this person and for this person, and check all that? No, all we need to do is we need to check if there are any hyphens, if there are any of these hyphens on the game board, right? Because if there are none of the hyphens on the game board, then the game is a draw. Okay, if no one's won, then we know that the game is a draw. Does that make sense? So we're going to come down here and we're going to say def check draw. And we're going to see whether this was a draw or not. And we are going to loop for one last time. We're going to go through that grid. So we're going to say for row in our self.grid. We're going to say for space in row. And we are going to return true if it is a draw. Okay? So as soon as we find a hyphen, so we're going to say if space dot get contents equals, and did I record what the blank was? Blank char. The space detects what the blank char. Okay, so we told our space, we gave our space a constant of blank char. Okay, so we can actually reference that now. So we can say if space dot get contents is equal to space dot blank char. So if it's the blank character, and at the moment that's a hyphen, but later on we might change it, and so it's better to put in space dot blank char rather than just put in hyphen, because then we'd have to update it here as well if we changed it from like a hyphen to a star or something, or just a space, an empty space. Whatever you wanted to do. So if space.getContents, so if the contents of my space is equal to whatever the blank character is for a space, then we know that it is not a draw. So we're going to return false. Okay, so we're going to go through all of these and we're going to check. And if any of them are equal to a hyphen, we're just going to stop. Okay, stop, we found it. We'll return false. It's not a draw. There's still an available space for someone to play. However, if that's not the case, and we get through all of them, and we don't find a single hyphen, then we're going to return true. That was quite nice, wasn't it? Quite simple, quite nice. Oh, lovely. Little nested for loop here, little if statement, 2 returns. Oh, it's classic programming. So now what we need to do is we need to say draw equals, and we're going to say self.gameboards, self.check draw. Okay, we don't need to pass in whose current turn it is because all we're interested in is whether the game board's filled up or not. We've already checked whether there are victory conditions, and we're going to check the victory first, right? So if victory is true, so if there is a victory, because the game board could be filled up, but someone could have won, right? So we want to check whether there's a victory first, and only if victory isn't true do we then want to say, okay, well, is it a draw? Okay, so we're going to check to see whether it's a draw. Okay, and if victory isn't true, so after this if statement, if victory equals true, we're going to say if, hate that, should be else if, come on Python, if draw is equal to true, then we are going to set some stuff, right? So we're going to basically just copy this, and we are going to just copy that and paste it down here. I don't feel good about that. I really don't. I feel like we could probably make this cleverer, much cleverer. But we don't need to have this if at all. In fact, we don't need this else either. We literally just need this. So for each player, we're going to set their status to draw. Maybe I'll do some kind of nice symbols either side of it. I don't know. What am I doing? And then we're going to change the result to draws, right? So we're going to add a result of draw to these players. And so if the draw, if it's a draw and it's not a victory, notice that I'm saying if victory is true first, and so I'm checking this. So if victory is true, we're going to do all of this code. And only if victory is not true, then we're going to check to see whether draw is true. Okay? Then if draw is true, then we're going to see that that this is a draw, and then we don't want to return victory actually. So we want to return true if someone has won. Okay, we want to return false if what? We want to return false. Well, we've got three options, right? We've got true, so I'm going to put in my return true up here in if victory is true. So I'm going to return true. If it's a draw, we're going to return none. And then if it's not a victory or it's not a draw, we're going to return false. So there's no victory. So only when we return false is the game just continuing. We're like, yep, let's continue the game. Does that make sense? Yeah. So if it's a draw, we return none, which is different to true, because when we return true from get victory condition, let's have a look here. We can see that self.gameover is equal to self.check victory condition. Okay. So is the game over? False. It's not over because no one's won yet. There's no victory and there's no draw. Okay. Oh well, if it's false, then we're gonna have the next turn. We're gonna keep playing. If it isn't false, then we know someone's won. We know someone's drawn. So in here, we can then say if self.gameover is true, we know that there's been a win, and if self.gameover is none, then we know there's been a draw because we're returning none when there's a draw. So let's see if I've programmed this good. Let's check this out. So I'm going to try and do a draw here, okay? This is going to take all of my brain power. Okay, so circles noughts have to go there. Crosses have to go here. Oh no, it's noughts here. Crosses here, noughts here. That was okay. Look, fantastic. So we can see they've both got the draw, okay, and they both have one added to their draws. This is fantastic. Okay, so now we have. Oh no. Oh no, it's all gone horribly wrong. Okay, this shouldn't be able to happen, right? So when I'm clicking the buttons, nothing should happen unless the game is running. So up here, can you see, this is our clicked function. This fires every time we click any of the buttons. And this should only be running if game over equals false. Okay, so I guess really we just got this if statement in the wrong position, right? We're going to take this if statement and we're going to pop it up here. If self.gameover equals false, then we're going to do this. We're going to check the new version of game over by checking the victory condition. And then I guess we're going to have to then check it again to decide whether we're going to do the next turn or not. Okay, so yeah, these have to happen in this specific order, and so I can't see a way of not having this if statement twice right now. It's probably really obvious, but so now hopefully we shouldn't get to this point here. You can see they've only played one game, and because I clicked around a little bit, they got 3 draws, and Bob's won 13 times. Oh dear. Okay, let's run this and see if this is better. So if we just get to the end of a game, I don't care who wins or loses. Okay, look, this is great. So Alice has won, and now when I click on something, nothing happens because our game is over. So I can no longer manipulate the board, which is exactly what we want. Okay, so the game is currently now in a state where nothing me as a player can interact with the game until I click on something that we as the programmer have put in for the game to restart, and then we can set game over back to false, and we can then start a new game, and we can wipe the board clean and do all of that great stuff. This has been a absolutely mammoth session. I'm sorry, I was again planning this for about half an hour. Thank you for bearing with me, and hopefully you've been able to follow along with getting those victory conditions in. This was a really big step in the game. Next version, we will be adding in a little bit of menu, a little bit of functionality there, and hopefully starting to really round off this game and how it looks. Once again, as always, thank you very much for coming along and programming along with me and dedicating a bit of your time to develop yourself and your skills and this program, and I hope I see you in the next version. And until then, take care, and I will see you then.